Hello, good morning to all. So, on the last turn, we studied about vernier caliper, screw gauge, simple pendulum, and how to do the experiments with this in the lab. So, today we are beginning with a fresh chapter, motion in one dimension. Now, if any body is moving on a straight road, in a straight line, in one direction, such kind of motion is known as one dimension motion. One dimension, you know dimensions? One dimension, two dimension, three dimension. So such a motion is known as one dimension motion. Okay? When a body moves along a straight line path, its motion is said to be one dimension motion. So we are going to study about motion in one dimension in this chapter. So let us continue. Now, what are scalar and vector quantities? I had mentioned in my first class, scalar quantities are quantities which do not require any direction, only magnitude, like distance. A body has moved 12 kilometers. No direction required. The body has moved 12 kilometers. Simple. So scalar quantities are quantities which have only magnitude and no direction. And vector quantities are quantities which require both the magnitude as well as direction. For example, velocity. A body is moving with 25 meter per second in north. So direction is required. So such quantities are known as vector quantities. Now we are going to see some of the examples of scalar and vector quantities. So we continue. Now, some of the examples of scalar quantities are distance, speed, mass. If you are measuring some mass, you don't require any direction. Only magnitude is enough. Energy, power, density, length, area, volume, time, temperature. All these quantities only require magnitude. They do not need any direction for specifying them or for knowing that what is it. Okay? And what are the vector quantities here? Displacement, velocity, weight. Weight is mg, no? So acceleration due to gravity. Which direction acceleration due to gravity? So weight, acceleration, force in which direction? Impulse, pressure, momentum, gravity. So all these quantities require magnitude as well as direction to specify them, and therefore these are vector quantities. So we move further. Now rest and motion, the two states, state of rest and state of motion. Okay. Now, you must have studied somewhere, a body continues to be in the state of rest or uniform motion unless and until an external force is applied to it. So, from this definition, what is rest and what is motion? When a body does not change its position When the body is stationary, the body is said to be at rest. Whereas when the body is changing its position continuously, there is displacement in the body is moving, it's changing its position, then the body is said to be in state of motion. So state of rest when the body is stationary, state of motion when the body is changing its position continuously. Okay, now if I have to define, what will I say? A body is said to be at rest if it does not change its position with respect to its immediate surrounding. Suppose you are going in a train. Okay, now you are sitting in the train. For you, the trees outside are moving, isn't it? Because you are moving with the train, so you are in a rest position with train. Whereas if a person who is standing outside and watches you in the train, the person will see that you are moving because he is stationary, he is not moving, and the train is moving and you are moving along with the train. Okay, so surrounding matters. So a body is said to be in the state of rest if it does not change its position with respect to its immediate surrounding, while a body is said to be in motion if it changes its position with respect to its immediate surrounding. Okay, now here I have taken some examples. A book lying on the table, a bench fixed in the park, this is in the state of rest. A flying bird, state of motion. A boy playing football, state of motion. Okay, so we move further. Now we have another part of the chapter, distance and displacement. Now what is distance and what is displacement? You have heard both these words. What is distance? When a body is moving, suppose a body is moving from A to B. So the distance covered by the body is the measurement of the length of A and B. Whatever is the length between A and B, if that is measured, that is the distance moved by the body. And displacement? Displacement is change in position from final position to initial position. Now suppose I talk about a body who is moving in a circular path. Okay, suppose there is a boy who is running in a circular park. Fine. Now suppose I take a point on the circumference of the park and I name it as A. Okay, just for making it easy, I have taken a point on the circumference of the circular park and I have named it as A. Now the boy starts running from point A and runs along the circumference and comes back to A. Okay, in this case, what is the distance moved by that boy? The circumference of the circle, the complete distance which the person has done is the circumference of the circle. Whereas, what is the displacement? The boy is back to its own position. He is back to point A. So there is no change in position. So displacement is 0. So must have understood, distance is the complete length traveled by the body, whereas displacement is change in position. So whatever is the change in position, that is displacement. Now if I talk about the example which is given here, you can see that the red line, that is the distance traveled by the body. And you can see that small dotted line, that is the displacement. So if I have to talk about the distance from A to D, I will go along the red line. And I have to talk about the displacement, I will go to the straight line from A to D. That is change in position. Fine? You must have understood distance and displacement. Distance is a scalar quantity. Displacement is a vector quantity. Distance does not require any direction to specify, whereas displacement needs a direction to specify. Okay, so we move to the other part of the chapter. Okay, so now we have speed and velocity. Now, speed, you must have done so many questions in mathematics regarding speed, distance, and time. So, speed is distance upon time. Distance per unit time is speed. That means rate of change of distance is speed. Distance divided by time is speed. So, rate of change of distance is speed. Whereas velocity, rate of change of displacement is velocity. Displacement upon time is velocity. Okay, so if I have to talk in terms of definition, the speed of a body is the rate of change of distance with time, and numerically it is distance s upon time t, and speed is written in small v. Okay, speed is a scalar quantity. Okay, whereas there are some parts also for this, but first I'll talk about velocity. The velocity of a body is the distance traveled per second by the body in a specified direction. That means displacement. The velocity of a body is the displacement traveled per second. Okay. Now, there are few things in this. Uniform speed. A body is said to be moving with uniform speed if it covers equal distances in equal intervals of time. This, you must have seen this in so many examples you have studied in classes 7, 8, and you must be knowing what is uniform speed. Equal distance in equal intervals of time, then the body moves in uniform speed. And what is non-uniform speed? When a body moves unequal distances in equal intervals of time, that is non-uniform speed. Suppose a body is moving first 100 meters in 5 seconds. Again, next 100 meters again in 5 seconds. Next 100 meters again in 5 seconds. So this is uniform speed. Whereas if the body moves first 100 meters in 5 seconds and next 200 meters in suppose 5 seconds. So this is non-uniform speed. Okay. Now there is one more thing, instantaneous speed. When the speed of the body keeps on changing, its speed at any instant is measured by finding the ratio of distance traveled in a very short interval of time to the time interval. This speed is called instantaneous speed. That means distance traveled in a very small time upon time is the instantaneous speed. That means speed at that very moment, at that very instant. If the speed is changing continuously, so speed at some moment will be calculated by distance traveled in very small time upon time interval. Okay. Now, average speed, you all have studied. Average speed is the total distance upon total time. Okay. Now, similarly, we have uniform velocity. Uniform velocity, if a body travels equal distance in a particular direction in equal intervals of time, said to be uniform velocity. Similarly, non-uniform velocity and instantaneous velocity is also the same for a body moving with variable velocity. The velocity of a body at any instant is called instantaneous velocity. Now, velocity is a vector quantity and speed is a scalar quantity. Speed is equal to v into t and distance is equal to speed is equal to distance upon time. So distance is equal to speed into time. Displacement also the same. So we move to the next part. So I have already spoken about uniform speed and uniform velocity when the body is moving with equal distances in equal intervals of time. That is uniform speed. And similarly, velocity. Okay. And when the body moves unequal distances in equal intervals of time, it is known as non-uniform speed. And similarly, non-uniform velocity. So we move further. Okay, now I'm talking about a case when a body moves in a circular path, the speed is uniform. So speed is the same when the body is moving in a circular path and equal distance and equal intervals of time. So speed is the same. Whereas if I talk about velocity, velocity is a vector quantity. Yes, the magnitude of velocity is same, but the direction is changing continuously at every point. Can you see? If you see in the circle, the body is changing direction at every point. At every point. If I talk about a triangle, if I start from point A and go to B, it is a straight line. Whereas if I turn from B to again go to C, I am changing my direction, isn't it? So circle is a polygon with infinite number of sides, and with this polygon, the body is changing its velocity every moment because it is moving in the circular path, and when the direction is changing, velocity is changing. And that is why there is a difference between a scalar quantity and a vector quantity. Vector quantities depend on direction. Velocity is a vector quantity. That is why velocity is changing continuously, whereas speed remains the same. Okay? So I think this must be clear. So we move further. Okay. Okay, so now we have acceleration and retardation. You must have heard about these words positively. Now, when a body is moving with a certain velocity, fine, suppose 20 meter per second, and force is applied on the body, that means if the accelerator has been taken and body starts moving with 50 meter per second, fine. So now the velocity has changed from 20 meter per second to 50 meter per second. And whenever there is a change in velocity, acceleration is produced and body starts moving more rapidly. That means with a greater velocity. Okay, so this is known as acceleration. There is a formula which we will derive later, but when the velocity of the body changes, then acceleration is produced. And what is retardation? Negative acceleration is retardation. Suppose a body is moving and brakes are applied and body is coming to rest or slowing down. So negative acceleration is retardation. So we will study in the later one. So I said acceleration is change in velocity with time. So what will be the formula? Change in velocity upon time. Here it is written speed because this is a printed thing. So it is change in velocity. Change in velocity upon time. That means change in velocity divided by time. Final velocity minus initial velocity upon time interval will give you acceleration. Fine. So we move to the further slide. Okay, so we have to calculate the formula for acceleration. So let the initial velocity of the body be small u and let the final velocity of the body be small v and time interval small t. So acceleration of the body A will be final velocity minus initial velocity upon time interval. Okay. and if you cross multiply, AT is equal to V minus U, and U will come to the other side with AT. So V is equal to U plus AT is a formula. Okay. A is equal to final velocity minus initial velocity upon time. You have to remember this: acceleration, final velocity minus initial velocity divided by time interval. And the SI unit of acceleration is meter per second square. Right? So we move to the other slide. So I've already spoken about retardation, that when a body is moving with some velocity and the body starts slowing down, the velocity starts decreasing and the body comes to rest, this type of acceleration is known as retardation. Negative acceleration is known as retardation. Right? The body is retarding, is coming to rest. Fine. So that is retardation. So now we have uniform accelerated motion, a kind of motion in which velocity of an object increases in equal amount in equal time intervals is known as uniform accelerated motion. That means the acceleration is uniform. Acceleration is not changing. Okay. That means the change in velocity is constant, and that is acceleration. So this kind of motion is known as uniform accelerated motion. Fine. So we move to the numericals of this chapter. So now we have a question. A car is moving in a straight line with speed 18 km per hour. It is stopped in 5 seconds by applying brakes. Find number 1, speed of the car in meter per second. Number 2, retardation. Number 3, speed of car after 2 seconds of applying brakes. I have taken a question which covers almost everything. The questions are very easy. You have done these questions in your earlier classes also. Try to do the questions. If still you have a problem, you may ask me in the comments below. Fine. So, solution number 1, speed in meter per second. So it is 18 km per hour. So kilometer when changed to meter, it will be multiplied by 1000, and hour when changed to second will be 60 into 60. So 18 into 1000 divided by 60 into 60. So it will come as 5 meter per second. Okay. Second part, acceleration. That means we have to calculate retardation. So we have to calculate negative acceleration. So let us see. Acceleration is equal to final velocity minus initial velocity upon time. We have studied right now. So what is the final velocity? The body is coming to rest. So final velocity is 0. Initial velocity we have right now calculated 5 meter per second. And what is the time interval? 5 seconds. Body comes to stop in 5 seconds. So time is 5 seconds. So what is it coming? Minus 5 upon 5. So minus 1 meter per second square. That means you can see negative acceleration, and that is body is retarding with 1 meter per second square. Fine. Third, speed of the car after 2 seconds. Now you know the acceleration. That means minus 1. And you know the speed. That is the body, the speed, initial speed, that is 5 meter per second. And you know here the time interval, that is 2 seconds. You have to find out the speed of the car in 2 seconds, after 2 seconds. So I am putting acceleration as minus 1. I don't know the final speed after 2 seconds. So I have taken it as x. I know the initial speed as 5. So x minus 5. I know the time interval 2. So I have written 2. So minus 1 is equal to x minus 5 upon 2. And that comes to minus 2 is equal to x minus 5. And so that from here x comes to 3 meter per second. I think the question must be clear. Go through the questions, try to do the numericals on your own. If you have any problem, I don't think so that you will get any problem, but you still have any problem, please ask me. I will do the questions and send it back to you. Okay. So thank you so much, class. We stop here. Take care. Bye-bye.